We're just going to solve this equation for the bell work here, and we see that we have x on both sides of the equal sign. But before we do any of that, principles of equality stuff, got to look for any like terms to combine or any distribution, which there is some distribution, we know because of the parentheses. So we'll distribute the 5 into the parentheses here, starting with 5 and 2. Now, distribution is multiplication, so it's going to be 5 times 2, which is 10. And then we look at this second distribution, which is multiplication, as 5 times, it's going to be negative 10x. So 5 groups of negative 10x's would result in negative 50x's. And we see that there's no distribution on the right side of the equal sign, so we just drop this down. So this is our new equation. It doesn't really change the overall value of the equation, it just changes the way that it looks. Now, if there were any like terms to combine, we would, but I don't see that there is any. So we're going to look to use principles of equality, which just tell us whatever we do to one side of the equal sign, we must do to the other side. Now, I'm just going to start with the first term on the left, which is 10. And we see that there's another constant here on the right side of the equal sign, the plus 3, or positive 3. And I guess I'm just going to choose to keep the 10 there, which means that I would have to get rid of this plus 3 right there. And by get rid of, I mean change to a 0. So how do you make a 3 a 0? Just subtract 3. But again, this is a principle of equality. So if you do it to one side, to maintain equality here, you're going to have to do it to the other side as well. So 10 minus 3 is 7. Then we can drop this negative 50x's, which now equals, even the negative 8x will drop. And then here, 3 minus 3, it does exactly what we want it to make it a 0. So this just makes the equation smaller, which is the whole point there. So I can see that now I only have constants here on the left side of the equal sign, and that means I can't have any x's being added or subtracted to it. So this negative 50x's, I got to make this one go away as well by changing it to a phantom 0 as well. So I'll do that by, since it's negative 50x's, I'll add 50x's. Remember that to make zeros, you got to either add or subtract. If we're trying to make a 1, which we will in the next part of the equation, we'll have to use multiplication or division. So I got negative 50x's plus 50x's, but if I add 50x's there in green to one side, I have to do it to the other side as well. So what does this do? It allows me to drop my positive 7. And then the negative 50x's in red plus the 50x's in green is going to 0 out as planned. And this would then equal negative 8x's plus 50x's would end up being 42x's. And then one final principle of equality will do it. Remember, our goal here is to make this 1x instead of 42x's. So how do we do that? Well, to make a 1, you have to use either multiplication or division, and I'm going to use division at this point. So I just take the coefficient 42 and divide it by itself. Because anything divided by itself is 1. It's just if I do it to one side, I'm going to have to do it to the other side. Now I think if you type into the calculator 7 divided by 42, it will give you a decimal. I do not want the decimal, so I'm going to push the double arrow button above the enter button, and it's going to give me 1/6. So I'm going to keep 1/6. It just looks, I don't know, a little bit better. But then I'm going to go back up here to the top, and I'm just going to replace the x's in the original equation with 1/6, just see what it gives me. So I'm just going to use the calculator. So I got 5 parentheses, 2 minus 10, and now I'm multiplying by 1/6. I'm using the n over d button. And I push enter, I get 5/3. Okay, so if I replace the x with 1/6, I get 5/3 here on the left. Then on the right, I got negative 8 times x, but now x is 1/6. And then push plus 3, enter. And on the right side, I also get 5/3. So that's a true statement, which indicates that our original problem there, 1/6 equals 1x, or original solution there is actually the solution. I'll make that a phantom 1. But now I can box this in, knowing that I have then found the solution to our original equation. And that's it.